Today in lesson 9, we are going to be talking about finding unit rates with complex fractions, which is what we did in the introduction. So when we are finding unit rates, it will help us to find how much something is for one item. And it is a extremely important skill because it will help you compare rates. And we are going to find unit rates in this first part on page 78, and then we will be comparing unit rates on page 80. So Max's favorite recipe for oatmeal raisin cookies makes 48 servings. He wants to make some cookies, but only has one egg. Max has to adjust the amounts of other ingredients. How much flour will he need? So we can look at the ratio, or we can look at the recipe, but we actually only need a little bit of information from the recipe. So they told us he only has one egg, and they want to know how much flour he needs. So those are the only two ingredients that we need. We only need to know about eggs and flour. We don't need to know about servings in here. We don't need to know about any of the other information for this particular problem. One thing that you probably did in 6th grade, and hopefully you remember, is this double number line. So when you make a double number line, you start at 0, and then you compare the two amounts. So for cups of flour on top and eggs on the bottom, we know from the recipe that 1.5 cups of flour goes with 2 eggs. But we need to know how much it is for 1 egg. So 1 is exactly halfway in between 0 and 2. If you look at the model it further down, it tells us that they did the same thing we did. It drew that line there, and 1 egg they found out was halfway between 0 and 2. So halfway between 0 and 1 and 1/2 is 3/4. So the answer is 3/4. However, did you know how to get from 1.5 to 3/4? There are several ways that you could have done that. You also might in the future have to find more than that. So what if he wanted to use 3 eggs? Then we could still do a double number line. We just have to be careful that we understand how to solve it. I'm going to show you 2 different ways that you can find unit rates today. So if you go to page 79, first our question says, why do you need to find the number that is halfway between 0 and 1/2? Well, we just figured that out, that 1 egg is half of 2 eggs. So we have to half the flour also. So why did we have to do that? Because we need half as much flour. So we also need half the amount of flour. So our question says, how can you find the number that is between 0 and 1/2? We're going to talk about 2 ways to do that. The easiest way is to think that, well, we need half of the flour. So of means multiplication. So since we need half of the flour, we can do 1 and 1/2 times 1/2. Now, good news is that you are going to get a calculator for this. If you didn't get a calculator, you would have to turn that into an improper fraction to multiply. We're going to use the Desmos calculator. If I were you, I would go to Schoology. I would open up that little calculator picture on the front of our math page, and then I would bookmark it because we're going to be using this a lot. So we have 1.5 times 2. To put a fraction in, I will press the AB button, but I need to put the whole number as a 1. So I use the arrow buttons a lot to move between the different spaces on the calculator. Or you can just type to get it in the cursor in the correct place. So notice 1.5 should look just like that. And we're going to multiply. So 1.5 times 1/2, we're going to need to use the fraction button again. So 1.5 times 1/2, it will automatically turn it into a decimal. But with cooking, we probably want to make it to a fraction. So the calculator also has this handy fraction button here that you can click, and we will get 3/4. So we just found out that we would need 3/4 of a cup of flour. So how many cups of flour does he need to use? We already showed our work up here, so we don't have to show our work. We just know that he needs 3/4 cup of flour. Another way we could solve this, and this is the way that I use the most, is to set up a ratio. Labels are important in your ratios. So the ratio of cups of flour to eggs is what we're talking about. And so we had 1.5 cups of flour for every 2 eggs, but we need to figure out how much it will be for 1 egg. So all we would have to do there, like we saw in the introduction, is divide. So I can divide, 2 divided by 2 is 1. So I would also just do 1.5 divided by 2. So question 6 says write and simplify a division expression. That's what we just did right here. 1.5 divided by 2. And we can still do that in the calculator. So in my calculator, I would still do 1.5. But this time, I need to divide that. Notice that it put the whole 1.5 in the numerator. I'm going to divide it by 2, and I will still get 0.75. I still get 3/4. If you are asked to show work on a problem and you use your calculator, you just need to show me what you type into your calculator. So we know that it is 3/4 cup for every 1 egg. So our unit rate is 3/4, which means the number of cups of flour we need is 3/4 times the number of eggs. So in question 8, explain how you found the unit rate. Pick the method that you like the best and explain how to use it. You could do the double number line method. You could say the multiply by the fraction method, or you could explain the set up a ratio and divide method. So pick which one of those 3 you like and answer question number 8. Now, question number 9 is asking us for 2 different parts of the recipe. So question number 9, go ahead and try those and then check them with the video. So question 9, I just used the division method. I set up my labels butter over eggs in the original recipe. 3/4 of a cup of butter will get us, is what we need for 2 eggs. So then I divided 3/4 divided by 2. You can see that work in the Desmos calculator. And for every 1 egg, it would take 3/8 cup of butter. So we would need 3/8 of a cup of butter every time he did 1 egg. Now question 10 is different because it says he only has 1 cup of flour. So now we're not using eggs, we're using flour. And we want to know how much vanilla we will need. Whenever we do unit rates, whichever one is the 1, that's the label we're going to put on the bottom. So this time he needs 1 cup of flour. So to solve this question, we're going to put vanilla in the numerator and we're going to put flour in the denominator. Go ahead and set up your ratio for vanilla and flour and then use the calculator to divide and check it with the video. So from the original recipe, you should have put 1 over 1.5, 1 teaspoon of vanilla over 1.5 cups of flour. And then I just did 1 divided by 1.5, and it gave me this decimal. But remember, click the fraction button, so we will get 2/3. So he will need 2/3 of a teaspoon of vanilla for his 1 cup of flour. Now on page 80, we're talking about comparing rates. So when we compare, we use unit rates a lot to compare because it lets us figure out how much something is for one item. I do this when I'm shopping a lot. Jose's mother is trying to decide whether to buy a 12-ounce package of coffee that is on sale for $7.50 when she knows that she can buy that same coffee for $9 per pound. The $9 per pound is already a unit rate because that means it's going to cost us $9 to buy 1 pound of, remember LB is pound, 1 pound of coffee. So she has to figure out the 12 ounces. How much is it going to be if it's $75 for 12 ounces? She wants to figure out how much that will be for 1 pound. So this is tricky because we cannot have pounds and ounces. So the first thing that we're going to have to do is we're going to have to convert ounces into pounds. They did that work right here in the model it, but I'm going to work through it a little bit so that you can see how to do that. You should know, hopefully, that 1 pound is the same thing as 16 ounces. So we have 12 ounces. And we're going to make that fraction and we're going to simplify it. So we had 12 ounces. So 12 ounces for 16 ounces is 1 pound. So 12 ounces over 16, we can use our Desmos calculator to simplify that. 12 over 16, remember, we're going to click the fraction button and we will get 3/4. So what we've figured out here, the number that we're going to use is $7.50 for 3/4 of a pound. And then they also showed you the double number line way. I don't like that way because I like that it shows you the proportional relationship, but it takes a long time. So it helps you understand better. It's easier, but it also takes more time to solve that way. So question 11 says the top number line is divided into 3 equal parts from 0 to 7.5. The bottom number line was divided into 3 equal parts from 0 to 3.5. How can you use this information to find the cost of 1 pound of coffee? Well, you would have to find just 1/3 of each of those numbers to find each of those place values. But you don't have to write in number 11 because we are going to solve it a little bit different way. Question 12 says, write the ratio that compares $7.50 to 3/4 pounds of coffee. Well, we already figured that out. $7.50 for 3/4 of a pound of coffee. Remember, the 3/4 came from, we originally had 12 ounces and there's 16 ounces in 1 pound. Now it says write and simplify division expression, which is what we are going to end up doing in the calculator. We would just do 7.5 divided by 3/4. So when I put that in the calculator, remember, use the AB button to put in your fraction. So 7.1/2 dollars. You do have to get out to the end before you click the division. Divided by, need the ABC button again, or the AB button, sorry. So $7.5 for 3/4, we will get 10. So it costs $10 to buy the coffee that's on sale. So which one was the better buy? Give me 1 second to get that to scroll right. Sorry about that. So the other coffee that she could have bought was $9 for 1 pound. The coffee that's on sale is $10 for 1 pound. So her original amount, that one that is $9 for a pound, it is the better deal. Why is it the better deal? Because it is cheaper. Where it says explain your reasoning, we just know it is cheaper per pound to buy the other one. But it was hard to figure that out when it was in pounds and ounces separately. Now 15 says, suppose you started the problem by converting 1 pound to 16 ounces. Would you have gotten the same results? Justify your conclusion. So you would have gotten the same thing, but we wouldn't have gotten $9 per pound and $10 per pound. We would have figured out how much it was for 1 ounce. So yes, we would still know which one was cheaper, but we would have gotten a different number. So would you get the same result? Yes, but we would have found the unit rate of dollars per, that's a dollar sign, dollars per ounce. Let me make that prettier. So we would have found how much dollars it was for 1 ounce instead of how much dollars it was for 1 pound. But we still would have gotten that not the stuff that's on sale was the better deal, but the other one was the better deal. Can you compare any 2 unit rates? Well, we just figured out from the original question, no, because the original question had ounces with pounds. You have to have the same units. So you cannot compare them unless the units are the same. So no, you have to have the same units. Now try question 17 and check it with the video. Remember, like we said, you have to have the same units. So since Rena is measuring in dozens of rolls, but Jonah is measuring. So first you can set up your ratios. I set up a ratio of flour to dozen rolls. So Rena was 2 cups of flour to 2.5 dozen rolls, and Jonah was 2 1/4 cups of flour to 3 dozen rolls. Now I can use my calculator to divide those and see which to find the unit rate to compare them. So after I divided, you can see my work over here on the calculator. This was Rena's work. So Rena did 2 divided by 2 1/4 to get, it was 4/5 cup of flour for 1 dozen rolls. But Jonah did 2 1/4 divided by 3 to get 3/4 cup. Now that is kind of hard to figure out if you don't know your fractions. If you're not sure that 3/4 and 3/4, we could find a common denominator to figure out which one used more flour, but here's another nice thing about the Desmos calculator. You could go back and you can click the fraction and turn it back into a decimal. So this would be 0.8, which is the same thing as 0.80, and this is 0.75. So 0.80 is bigger than 0.75. So we just found out which recipe uses more flour. Rena's uses more flour because she used 0.8, 4/5 of a cup of flour, instead of 0.75, 3/4 of a cup of flour, and 4/5 is bigger than 3/4, which we just figured out from the decimal answers.